Yeah, I asked this question because I have obviously headsets myself. And when you just got it, it's like a brand new toy, right? You want to play with it. And then after a couple of hours, it's collecting dust. Which is strange because I'm also an XR researcher. And most of you guys are XR researchers. And I tell myself, yeah, I'm going to use VR chat. I'm going to use if I had a Vision Pro, I'm going to use the pass-through face and so on. But I don't end up using it. I remember speaking with some colleagues right before, like a few months before Vision Pro was about to be launched. We were saying that XR is lacking a killer app, but it's Apple. They won't make a mistake. So when Apple releases the Vision Pro, things will change. Did it though? Did it actually change? Didn't change, did it? So you have a Vision Pro, right? Frederick, was it? What do you do with it?
Yeah, that's exactly what I wanted to say. Like,
Yeah?
sometimes it's nice if you are in a narrow space to have a big screen,
Yeah.
everything. But then again, after maybe an hour or so,
Mm.
it stops being fun.
Stops being novel, right?
Yeah, or
Yeah.
you're like done with your task or
Mm,
whatever,
mm.
and it's not worth the price, I would say.
Yeah, so that's tricky. I like the question in the previous talk about immersion being a must-have instead of nice to have. I think that's really a really good question, and that does resonate a lot with the talk today. People certainly have tried to find some use cases when Vision Pro came out. In some ways, sacrificing safety. I wouldn't recommend you to do that. But clearly, it didn't work out as well as we were hoping it would. And there are a lot of barriers, which is something I want to talk about. So the purpose of my talk today, the topic is actually why AI and XR, right? Why we need to really understand its key use. And I can say for certainty that I can't say completely, what the answer to this question is, but at least try to explore some topics which I believe can contribute towards sort of the strength of what these systems can offer. And I would like to stress on the use of empathy, understanding others, the use of assistance, and the use of augmentation. All right. So a little bit about myself. I know I skipped the introduction of myself the first day, so because I'm going to be introducing myself today. Um, so I'm actually Malaysian. I think there are some Malaysians online joining here. Hi guys. Um, so my original background was engineering, and I pivoted quite a lot actually. So I was engineering originally, degree and masters, and then I went to Japan for PhD for 3 years, and I pivoted to design. It's a design school, KO Media Design. Then afterwards, I was in New Zealand for 2 years in Mark's lab, actually, empathic computing lab, as a postdoc, bioengineering. And then I was back at KO for 2.5 years as an assistant professor, so back to design. And now I'm at Auckland, computer science. So I do jump around here and there. When I was in Japan, I was directing a group. It's called Physionetic Interactions. It's actually part of a big university. It's a part of the big government-funded project. Actually, if you guys recall the talk by Kasahara from Sony, he and I were actually part of the same big project. It's that cybernetic being moonshot project, which I'll talk a little bit about that later. And then now that I'm in New Zealand, I am directing a lab. It's called Inclusive Reality Lab, and also co-directing with Mark the Empathy Computing Lab at Auckland. Also, I welcome interruption. So if you want to interrupt me with anything, online or offline, just raise your hand and we can discuss at any time. So a little bit about XR, right? The numbers are not looking very good. 60% decline in AR/VR headset shipment year over year. So that's quite a big number. And as opposed to AI, 20% increase in global AI adoption year over year. Because AI is very clear, it's very useful, isn't it? XR researchers don't use XR as much as we thought we would, but everyone, regardless if you're a researcher or not, uses AI. And I think that's a very interesting thing to look at. So I think there was an article a few years back called the metaverse. I like how it was spread. We don't use the word metaverse as much anymore. I think it was used a lot by Meta a couple of years back, but now they too pivoted to AI, isn't it? It's all about the lack of a killer app, right? And among other things, there's a lack of comfort, the lack of good pricing. So XR falls behind. AI, on the other hand, is ubiquitous. the use of XR isn't. So to, the question earlier about immersion, what is a must-have for immersion is really a very tricky thing. And that's why if you just talk about immersion, it does tend to lean towards gaming. That's the easy answer, right? Create a gaming app, a gaming system, and then we can say that's where immersion truly lies. The benefits of immersion. A couple of years, well, maybe not so long ago, 1 or 2 years ago, I found a very interesting article. My face is blocking the text. That you look at all the marketing material for XR on Vision Pro, right? They show people happily using the headsets. But then the reality is not like that. In fact, there are articles saying that Vision Pro is going to make loneliness worse. It encourages users to enter their own virtual world, removing the needs to interact with others. It looks awfully isolating, which is supposed to be the opposite, right? We were supposed to be promoting a system that can bridge physical distances, fancy avatars here, and so on and so forth. But then it looks awfully isolating. And it puts you at the center of your own little screen-filled world. And I find myself looking at this statement a lot and thinking, with all its potential, why is this happening, right? Because these systems are supposed to bridge gaps, not create gaps. And that's what my research is a lot about, how to actually bridge gaps with this sort of emerging tech. So to me, my focus in AI and XR is not too much about research on how to make AI perform better, how to add more billion parameters in there, or how to have a better optic system in XR headsets. These are important research, no doubt, but that's not what I would like to explore. To me, my research question is all about what context makes AI or XR, or both, truly useful, right? It's strong use case scenarios. Again, I don't know the absolute answer to this. Yeah, I'm still exploring it. And that's the purpose of my research. So a little bit of inclusive reality lab is quite new actually. It just started this year, and I'm still looking for a physical space. So we don't have physical space yet, but I have members, so that's nice. So the core vision is a future where technology bridges social and ability gaps and fostering an inclusive pro-social society. So I'm a HCI researcher, human-computer interaction, which is why I'm jumping around engineering, design, computer science, psychology, you name it. I think these are all very interesting topics, and HCI basically merges everything. So it's HCI lab in computer science in the University of Auckland. I call it inclusive reality because to me, inclusion is about acknowledging diversity where everyone thinks and act differently, and also empowering diversity by bridging gaps. So I would like to highlight this topic by separating into three main research areas: understand, assist, and augment. Okay, so I'm going to be presenting a few research projects across these sort of three main umbrellas. Just a few. I just handpicked a few of them. There are more out there. I just chose the one that's specifically related to AI and XR. Okay, so we're going to start with understanding. Understanding cognition. So to promote inclusion, we first need to understand. To me, that's the first step. How does AI XR affect our cognitive states? How does it affect our emotions? How does it affect our behaviors? Okay, so I think that's a very sort of first step. And I believe that these technologies, AI and XR, is something that can really promote the next level of understanding. So I'm going to share a couple of research. What I'll do is I'll start off with a sort of like a general research question. I'll show a video. Most of them will have a video, and then a very quick results. Now, I will say that a lot of this research is from the past 5 to 7 years until recently. I don't quite remember every detail because usually every year there's like 20, 30 research outputs. So I don't remember everything. If I can't answer a specific question on exactly how it's implemented, I'll probably just direct you to the paper. But if you want to speak with someone about it, then probably I can direct you to the first author of the paper, which is usually one of the students. So the first question is, do we trust AI agents? And I think this is quite a timely question. What happens when we trust or distrust them? So this research is about designing a task in VR where an AI assistant complete that task. However, we adjust the performance of that AI. It is either 100% accurate or 50% accurate. When we say 50% accurate, it basically means not accurate at all, right? Because 0% accuracy is the same as 100% accuracy. You know, if you know it's always lying. So if you never know when it's lying or not telling the truth, is the hardest, it's hardest to trust it. So do we trust it? And also a very interesting variable that we tweaked here is that when you're under different levels of stress, different level of cognitive load, how does your trust towards something changes? Perhaps under a do or die scenario, will you begin to trust AI more or a little less? And also what happens to us fundamentally if we trust it? So yeah, this work was in 2020. Evaluating trust towards virtual agents. So we measured a couple of things. We measured skin conductance, heart rate, and EEG, brain signals.
Baseline cognitive load test.
This task is called the NBAC task. It's a way to artificially induce cognitive load. So this is the first stage where we try to induce different levels of cognitive load to the user, then present them with the task. The task is very straightforward. It's just a shape finding, object finding task in VR. Maybe I just quickly pause that. So the thing in the pink background, the red box, is what you're supposed to be looking for in the virtual environment. That's a very simple task. And you have a little AI thing in your head, in the headset, telling you, is it to your left or is it to your right? And then we observe the behavior. When it says left, do you turn left? Or do you hesitate before you turn left? Does your heart rate change? Does your brain signal change? So we try to evaluate your physiological changes as well as your behavioral changes. So the AI here has no form. It's very, I call it AI, but it's just left or right. So it knows where the object is, obviously, and it tries to give you feedback on where it is, and then it becomes your decision to trust it or not. And it's based on different levels of stress or your stress at that point. So there's no significance in terms of head movement behavior, but we did find that inaccurate agents reduce the alpha band power, so it's a specific frequency range in the brain signal, which is tied to increase in cognitive load, increased stress. So behavior-wise, we don't really exhibit as much in terms of whether we trust or distrust something, but it can clearly be shown in your brain signals. And that's something that a couple of research now, so this is 2020, but a couple of research now has built upon a result like this to reflect on your brain signals when we want to see, evaluate your trust towards a system, an AI agent. These days, obviously, it's more complex than just left or right. So there's a lot of room for building on research like this. There's one research here about memory. So I think this one is sort of related. What is the relation between memory and VR, right? Like immersion, how does it affect the user's memory? So this research is on emotional autobiographical memory, which is a kind of specific memory. When we say autobiographical memory, the easiest way to put it is a specific memory tied to your personal experience in the past. And usually it can be also tied to a specific emotional moment. So we call this emotional autobiographical memory. So we designed a task in VR where a prompt, this is actually an actual psychology task, but not in VR, where a prompt will trigger your memory recall. So we want to know, can VR help in memory recall? What happens when we recall memory? So usually is there some kind of change in our physiological state? Or can we predict memory recall as well? Yeah, is there a possibility to predict memory recall given the right kind of stimulus in a virtual environment? Where no fancy videos here, but at least there's a nice banner image. So the setup isn't too different from the trust system, where we put on sensors to evaluate their heart rate and skin conductance. And the way how it works is that we first provide a emotional word stimulus, and the emotional word is from a sort of emotional word dataset, public dataset. The exact name I don't recall, but you have to find it at the papers. I can easily share it with you. So we say, for example, a word is presented, loved. Then after the word is presented, there will be a session where you try to recall a specific memory in your lifetime, which turns up in your mind when you see the word loved. And during this process of recalling, we record your change in physiological states. And finally, with a subjective questionnaire asking you how sort of realistic this memory recall is. So there is some clear changes in terms of your skin conductance, as well as your eye blink rate during autobiographical memory recall. So skin conductance maybe is difficult for you to work on here if you don't have the sensor, but blink rate is potentially something you can work on if you have a Quest Pro with eye trackers. And on the prediction side, there's actually an accuracy of 77.1% generalized AM recall. So what this means is that if we have this model deployed to any of us, it should have an accuracy of 77% to detect when you're recalling a memory. But if you wanted to make it better, you can have it personalized, meaning that the model is trained only with your data and no one else's. In this case, it will go up to 95%. So that's just a table of different kinds of machine learning classifiers. And EC is a ensemble classifier. We tried a couple of things, random forest, RF, KNNs, K nearest neighbors. Yes?
Does it mean when people are telling made-up stories that they probably would not recall?
Yes.
Track that?
Yeah. So that's the difference between false memory. So actually, that's a great question, because I think just last year or this year, there was a very interesting paper about how XR creates false memories. So I think that could actually relate quite to that. In this case, it's personalized memories, and also memories tied specifically to an emotional point in your life. But I do encourage to read the false memories paper. It's quite interesting. Also, can we understand a person's emotions just by looking at them? So this is actually part of the Japanese research program, cybernetic being moonshot. So to give a brief introduction, actually this moonshot research is quite aligned with what Tim mentioned earlier, his work on avatars. So it's basically about avatars. But the way how it was envisioned is more like, when you say avatar, you could think of the movie, right? The Blue Aliens, one of the Blue Aliens, or maybe the cartoon. So actually, it's more closely related to the ones with the Blue Aliens. If you guys watch the film, it's about a guy who is actually disabled, right? But after he inhibits this, he jacks into this blue alien character. He can now run faster, jump higher. So actually, that's the vision of cybernetic being moonshot, to design and develop avatar systems that aren't just representations of the self, but to enhance our abilities. And that is something that we've worked on in the past few years, at least for me, when I was there as an assistant professor. I was more focused on the virtual side. Kasahara was more focused on the physical robot avatar side. So in this case, our question is, can we design avatars that allows, like the moment we look at someone's avatar, we understand their emotional states immediately? Because humans are very subtle beings. We may feel, like I may be feeling very anxious here sitting in front talking, but you can't tell, I hide it very well. So we all try to hide our emotions, especially to people who are not close to us. And so it becomes hard for us to tell how a person feels. So our question here is, can we develop an XR experience where we can actually reflect this emotional state via avatars? Actually, this system is more complex than that. It does look at virtual avatars. It also looks at the way how robot movements, like small robot, actually tangible, small tabletop robots move around the desk. Can it also reflect emotional states? So it's more an experience as opposed to a full research paper. And also, how does it impact social communication? So I'll show you a video on how that works. Yes.
Build that avatar.
So you can have a look and trust.
That not just can be, but build between.
Yeah. So not so detailed, no. So in this work, it's more like initial sort of. It's not a full research here, actually. It's a demonstration, just like an initial exploration on how people perceive this avatar. So nothing so detailed yet. Unfortunately, we didn't go too much into the actual publication of this kind of experiments. But I do want to show an initial exploration, and there are a few papers that looks into this a little bit more, just not from me. But I'd like to show you this experience a little bit more. So the way how this works is a multi-user interactive experience. Actually, this video has a bit of a problem where it keeps pausing in the middle, so I'm gonna have to intervene. Where people are engaging in social communication, and we want to see how reflecting via avatars allows us to understand emotions better. So this is actually a machine learning, but this is actually developed by Tamil, who's sitting behind quietly. So this is also an ensemble classifier, gradient boosting classifier, where it looks at sort of different kinds of models, and does an ensemble prediction. This is using heart rate and skin conductance with an accuracy of 87%. And the way how it works is, once we've predicted the person's emotional states, usually we use the arousal valence emotion model. And yeah, this is the page I want to show you. So we ran a couple of workshops co-design workshops, asking people at different emotional states. And then we have this sort of sketching task, sketch out an avatar that best represents yourself in your emotional states, the kind of color, the kind of particle effects. And we came up with this four effects with different arousal and valence levels. So the idea is that when your emotional states change, your avatar reflects that very clearly. It transitions to these four avatars. So when you look at someone, you have a general idea. Now it's tricky because we don't all perceive emotions the same way. So that's another research gap. I can't say for certain that this will be how it works for you. It's just from our brief workshop. I believe it's like 12 to 15 people. We sort of co-design this avatar shape and form. And ideally is that you can personalize this the way how you see fit in the future. So this is a multi-user environment where you are chatting with someone else, and we present different kinds of topics that would make you stressed or calming or even angry, and see how it changes your avatar and see how it changes the communication dynamics. I'm not sure what's wrong with this video, to be honest. So I'm just going to jump around. And this part is the tabletop part. So this is actually a tabletop. Well, here's the full system. But then there's also a little miniaturized robot that moves from one end to the other that reflects the communication dynamics and the way how it sort of rotates and turns. That's actually related to kinesthetic empathy, which is empathy via movement. Usually it's more, you'll find papers on like dances and so on. But here we're trying to see through a robot movement as well. And see how people perceive that, because this is actually a public demonstration. So this allows the audience to also sort of try to understand the emotions of people within the VR space. This is the sensor that we use. So this is the Emotibit sensor. It's actually quite low cost. So if you're looking at a sensor for skin conductance and heart rate, I do recommend Emotibit. I think it's like $100 maybe, or 150. This is the Sony Toyo. Unfortunately, you can only find this small robot in Japan. Sony Toyo is called. And then two users will be communicating with each other in the virtual space. We designed a few conversational scenarios for them to talk with each other and see how their emotional states change. One of the great outcomes, I think, was that during the demonstration, there were some people. So the way how it works is that people would just, random audience, they come, they join the demonstration, they'll use it, try it out for like 5 to 10 minutes, and then they can leave. But the interesting part is that some of them who did the demo, they didn't know each other. They were total strangers. And right after the scenario, they became friends. So I think that was pretty successful. Unfortunately, we didn't do further evaluation, but it did help bridge their social gaps, I think. So I was quite happy about that. I can't say it was effective for everyone. Some say that it didn't work very well. Some say that it didn't reflect their emotions very well, and that tends to happen. Emotions are very complicated. There's no one size fits all. But for a proof of concept, I think it was quite interesting. So I'm going to move on to assist now, and a couple of projects on the assistance side. So to me, we sort of look at the next step beyond understanding, right? To me, empathy is good and all, but what's the next stage, right? Once we understand someone, how can we assist in an actionable way, with actionable outcomes? So how can AI XR let us help others, and how can it also let us help ourselves? So the first question here is, can we design an assistive wearable for vision loss? We developed a low-cost, lightweight XR. I say XR because it's a hardware system from the ground up, specifically to simulate vision loss. It's not any of this Quest Vision Pros that you all are using, but it's meant to be low-cost, lightweight, and it's meant to simulate peripheral and central vision loss. So how to make it low-cost? How to make it lightweight? How to evaluate its effects, right? So it's called a visual impairment simulator, and that's how it looks. So it's just a little LCD screen with eye trackers. That's the pupil lab eye trackers. So there's a world camera that sees what you see, and there are two cameras, cameras that sees what your eye sees. Sees your eyes basically. So this central vision loss is actually quite annoying. Wherever you look at, there's the black spot, but that's how it is. And then I'm going to skip a little bit ahead. That's peripheral vision loss, and we have parameters that allows us to tweak how serious the central vision loss and peripheral vision loss appears to the user. And the whole reason why we want to build a headset like this is because we didn't want to have a big bulky system headset just to simulate these two visions. It's significantly lower cost. Well, the eye trackers are not exactly cheap, but it can be. It's just enough for the prototype. And doesn't induce any kind of motion sickness that typically VR headsets do. So just some examples of real world scenarios. So looking at trying to read text when you have central vision loss, for example. This is actually really quite hard. Yeah. So a quick evaluation here just shows so the way how the stars is designed is that we have several key points you need to look at on a whiteboard, and then we enable this vision loss and see how well can you follow these points. So peripheral vision loss, the ones in brown, you can see that generally is much smaller than when there's no vision loss. So it's just sort of a quick evaluation to reflect how much this has impaired your vision loss. All right, let's move on to the next project. Next question is, can we design an assistive wearable for dementia? Dementia is tricky because it's not a vision thing, right? It's a brain thing. So it takes a lot of understanding and interactions and co-design with professionals for us to understand this. So we developed a low-cost AR system to simulate how dementia patients visually perceive the world. So how do dementia patients see the world? How do we simulate that? How do we relate its effects, right? Well, I'll let the video play out as I explain. So this project is called Dementia Eyes. And these are some of the simulated effects: vision field defect, and you see the difference with normal view, decrease in color sensitivity, delayed pupil dilation, pupil contraction, presbyopia, and yeah, those are the main symptoms. So we got this information through an extended co-design process with medical practitioners and caretakers. It's difficult to actually directly engage with dementia patients because they can't give a direct feedback. So the purpose of this system is actually to have the caretakers use it to understand a little bit more how dementia patients see the world, so that we can use it to design the environment. A very interesting feedback that we got was that in this hospital that we were doing the co-design process and testing, the ceilings had a very interesting, well, to people without dementia, it's no big deal. It's just a ceiling with some lines on it. But according to the doctors, they say that when the dementia patients see the ceiling, it looks like worms moving around. And that's not something that we can tell. That's something that only is the feedback shared to the doctors, who then told us about this, among other things. So the visual feedback that you see there is not the trickiest thing. In fact, these are all just Unity post-processing. You can easily develop these things. But getting the parameters right is the hard part, right? We need to truly understand how dementia patients see the world. Actually, we just use the iPhone. So this is actually mobile VR. It's something that most research don't use anymore, but we use it for a few reasons. One, we want it to be extremely easy for doctors to use. So they literally just need to launch the app, put it in there, and it works. They don't have to connect to PCs and all that fun stuff. Launch Meta Horizon, and they don't have to do that. They just use an app on the phone. But as you may also notice, this is pass-through. So we try to enable the cameras from the iPhone. But iPhone cameras, I mean, there are 3 cameras, but they're not built in a way that's stereoscopic, right? So you look at the pass-through devices that you have, they are built in a way for cameras to be stereoscopic. iPhone's cameras are not stereoscopic. So that's also a reason why people don't do pass-through with iPhones or like smartphones. And to create stereoscopy image is basically fake stereoscopy. So you just duplicate the camera image and you just sort of move it a little bit so that it sort of, simulates the distance between the two eyes. People normally don't do that because it creates a very poor depth of field, very hard to focus. But poor depth of field is something that dementia patients face. So we use it to our strength, and we use that to simulate how dementia patients perceive the world. So in all honesty, it's not the most comfortable thing to put on. It's not supposed to be comfortable. So when you put it on, you understand, like, it's very hard to just walk through a hallway So let's put a support bar here, or let's put some chairs here. The lighting in the room is very bad because pupil dilation is very slow, or is affected by the vision. Let's have a brighter room, or let's keep the windows open. So this really helped with the design process of the, let's say, hospital or the caretaker's space. Yeah, this is just some quick event. Yes, Mark.
Well, the dementia app.
Yeah.
If that's the app that's available, or is it the research?
So it's yeah. There was a plan to make it available. It's not yet available. It has been patented, but it's not yet available. So actually, my plan is to have it recreated in Auckland. So this was a study in Japan. I'm trying to recreate it in Auckland actually, and have it as an app that people could try and use it. So not for any kind of monetization, because it's there are a lot of rules and regulations around these things. But I would like to have an app that's easy to try out, and with parameters that you can adjust and how serious they are. The ideal way is that people have different levels of dementia, and so you can tweak like this, how severe it is, how mild it is, for example. So I would like to have it out. It's not out yet. So for now, if you want to learn a little bit more about it, you just have to rely on the research paper. Otherwise, I'm happy to talk a little bit more about it.
For caretakers to.
It's for caretakers, yeah. Main use is for caretakers, but otherwise, it also allows us to empathize with people with dementia a little bit more. But main use is for caretakers. At least that's the goal of it. All right. This is the latest one. I think this is also maybe it reflects one of the research projects here. Can we use VR as a ubiquitous safe room? So this project is a VR environment specifically for emotional regulation, and actually for neurodivergent women and non-binary. Because interestingly, if you try to find research on safe spaces, using VR, there's quite a few out there, but not a lot that caters to women and non-binary. That's a research gap that we established. So we were trying to develop a safe room, but looking at literature, most of the sample tends to be male, or at least male dominant. So that's a research gap that we found. And so we want to understand, for a safe room for this specific target's user, how is it different, and how can we, really co-design with them? So that's the main reason. It's a research gap that we established. So this work is actually not published yet, but I'm hoping that it'll be published soon, because the reviews are quite good. So I'm just staking on it being accepted in the next few weeks, actually. So it's going to be hopefully out in ISMAR 2025. If it isn't out, then just keep it to yourselves. But I think it will be out. So it's called Portable Silent Room. I think it's quite interesting to use VR for this, because it's literally a portable silent room. You can just pick it up and you're in your own silent space, a safe space.
Options for engaging in creative.
So it went through several levels of iterations, and this is the final prototype, which is a combination of different kinds of modules and scenes and tools based on the feedback that we've gathered. So I'll have the bullet points listed afterwards. But it's a combination of this audio effect, environment effect, the amount of agency you have to the environment, what can you change, the lighting, what are the interactive tools provided within the space that allows you to explore your creativity a little bit more, because it's a VR space. So technically you want to have a certain level of agency as well over it. So this is just a list of modules and tools provided within this sort of safe room space based on the feedback that we gathered from the target user. Co-design. Yeah, it's co-design process. So it's basically through workshops and focus groups. So the simple way is you sit around in a room, do group interviews, let them do sketching exercises, and truly understand these things. And once we've gathered all the feedback, let's say, I forgot the exact sample size, maybe it's like 40 or 50 feedbacks, then you do, yeah, it has to be, and it can be bigger, actually, ideally it should be bigger. And then we do a good sort of qualitative analysis, usually some kind of thematic analysis. So from all the list of feedback, we do thematic analysis to extract, let's say, 4 to 5 themes. And from these themes, we try to derive the designs. So if you were to, let's say, replicate this, you don't necessarily have to follow exactly the final prototype, but you should ideally try to follow the themes that we've extracted, which is something that I'll share in the next slide. Yeah, so this is the, no worries. So here's sort of the outcome of the prototype for this system. So it's just sort of like a combination of, there's a breathing practice tool as well. So in this, I think it's a kitchen, actually, the breathing practice is in the kitchen room. And then there's also a sketching tool, a creative expression module for you to express yourself. So some of the key points here is that it should have a visual focal point of relaxation, a space with a sense of safety and security, tool for guided breathing, natural space for forest bathing, an area with a sense of freedom and openness, so you let them transition around, adjustable audio stimuli, and module for creative expressions. So this is some of the sort of main points from this portable silent room. So when it's out, I'm happy to share the paper a little bit more. Otherwise, what you see is what you get. And let's move on to the third topic. Do I still have time? All right. Yes.
Mentioned about the risk or worry they have, because if they're in a public space, although you transported them into a safe space, in reality they're not safe. They're still
Yeah, that's true. Yeah, it's still, in the end, it's virtual, isn't it? Yeah, no, you're absolutely right. So it's just a momentary peace, isn't it? But they'll take that over having no peace, isn't it? So it's still, I think that's actually one of very strong tools of immersion in this case. I think it's really helpful. So it's not going to be an absolute solution. It's not like they're physically transported anywhere, but at least for a brief moment, they have the perceived idea that they are in a safe environment. I think that's helpful enough. Yes.
Did you find any salient differences to the pre-existing literature of music?
Yeah, there are. So even for the previous literature on male participants, there tends to be some kind of competitive tool that needs to be in place. Something that you need to do some kind of yeah. That's right. Yeah. So these don't exist in this tool here. And this tool is just more about purely self-expression and freedom and self-expression. So that's sort of, actually that's the key feedback from the reviewers as well. It's not like it did very, I mean, I had to go through several rounds of rejections to reach this point. So just to be clear, all these projects, it's not like without and it just works, right? It doesn't work that way. Usually it went through a couple of certain levels of rejections in previous submissions to be able to reach the of revision. So yeah, that's a good question. So that's exactly what the reviewer asked us as well many times, like what's the key differences with other kinds of safe rooms, because there are a lot of works on this kind of safe room environments, environments for well-being, mental well-being, so on and so forth. Okay, so I'll move on to the third point, which is augment. So to me, this I feel is, I guess, a little bit more unique to my vision of inclusion, is that to me, the future vision of inclusion lies beyond our current abilities. So once we have assisted people, can we also look at technology to perform beyond our abilities? Sort of the next step, right? We keep moving forward. So people will change. Human augmentation may be a bigger thing in the future, right? Implants, so on and so forth. So at that time, can technology create a new form of perceiving reality, and how can it sort of help us be beyond who we are today? So the research here is more about asking a big what if question, and doesn't exist in current society, but it's a potential future society. And I think that's a very important question to ask if you plan to be a researcher, because I think that as a researcher, you should always envision things 3 years, 5 years, 10 years in advance. Otherwise, you get obsolete really quick. There are big companies out there with a lot more resources than you have. So you need to be able to think out of the box. And this section is a lot on thinking out of the box. So I'm just prepping you on some of the crazy things that may appear in the next couple of slides. So the first question here is, how can humans have 360 vision? I'm not sure if you thought about it. Maybe you have. And researchers certainly have thought about it. I'm not the first to have thought about it. Human field of view is approximately 200 degrees horizontally, 135 degrees vertically. So how do you get 360 vision? Previous work have already done this. So I'm not the first to have done it. And the way how you do, so let's say, how can humans have 360 vision? Is that even usable? And actually, the more important is the second question. So the way how researchers have done it in the past is this idea, right? The Earth itself is 360, but we are able to see the whole Earth. Why is that? because of that view, right? The square view. It's called equirectangular view. And that's how it is in a lot of 360 cameras. If you load up images from 360 cameras, it comes in different formats, but in a lot of cases, it's this equirectangular view, and then they wrap it around to become 360. So essentially, when you look at a view like this, you're actually seeing all around the world. If you look at a 360 camera vision of this view, you're essentially seeing all around you. So the edges, the left and right, is all the way behind, and that allows you to see all the way behind. So clearly there's some distortion put in place, but there are works in the past where if you look at this view is just presented in front of you as you walk around through a 360 camera, you essentially see all around you. But it's not the most usable. So I was trying to think about how to make something like this a little bit more usable. It's because of the distortion. It's heavily distorted, right? We are not programmed to see, we are not built to see views like this. So this work is called OmniView. This work is called OmniView. And the idea is that where you're paying attention to will change its distortion. So if you're looking at a certain point in this equirectangular view, it will adapt and be able to perceive that space. And we look at different ways to do it. One of it is pointing with the controller. So you point at a certain point and then the distortion will change to be able to see it, or through eye gaze, or through facial detection. So we look at this sort of different ways, different modules to make 360 vision usable for human being. So we made a study in VR. You create sort of 360, these sort of objects that appear around in this environment, and you try to perceive, okay, is it to the left, is it to the right, is it to the front? Just to understand your spatial perception in this space. So we also created sort of different tasks. Trying to talk with someone, trying to read text, trying to walk around, and just to investigate how usable it is for users with 360 vision. So our idea is that there's a good chance in the future that people will have 360 vision. And when that time comes, we are prepared for it. But this is just the beginning, right? Let's say, so this first question is just how to make 360 vision usable. So then the next question is, let's say it has become usable. What then? So in such a future, everyone would have 360 vision. Everyone will have augmented visions. We can see all around us at all times. And that would change how social interaction works. So that's the next research question, is that let's say everyone has 360 vision, how will this affect social communication? And so we look at this thing called F formation. It's called facing formation. And that's actually a sociology study where people have different ways of facing each other, face to face, side by side, corner to corner, which kind of dictates a couple of things. It dictates the hierarchy in the conversation. It dictates the understanding of the topic, so on and so forth. So it will be interesting, right? Because you don't need to face each other when you have 360 vision. You can do back to back and still be face to face. So I think that was a very interesting question to look at. And so we try to investigate this social effect of 360 vision. And hence we have something called multiplex vision, and it's now two-way. So not only can you see 360, so the guy in the fancy headset can see 360, we know where he is looking at in 360 from outside. So if he's looking behind, his eyeballs will go behind, or his virtual eyeballs will go behind. So this is sort of attaching a couple of displays all around the headset to reflect his vision. And we look at this in the different kinds of modalities. So it could reflect where his eye is looking at. It could reflect the actual camera scene on where he's looking at, among other things. And also different kinds of view for him inside. He could look at it as an equirectangular view. He can look at it as a layered view, which is horrible to be honest. But he can look at it as a layered view, front and back. And also from the outside, you can see where he's looking at or his eyeballs. And then we try to investigate how communication works at this point. So I like works like this as well, where we try to push the boundaries and ask a big what if. It's not something that can be accepted by everyone, but to me, this is the best kind of research questions. The kind where not only 50% agrees that it's a good research question. That's the best kind, in my opinion. So yeah, how usable it is? Obviously, it's not very usable. It's very heavy. It's very uncomfortable. But that's not the point of it. The point of it is to investigate the social interaction. And the sort of potential augmented future. Yeah, so we sort of propose new paradigms for F formation. And in the future, so the black characters are basically, people who are using the headset and how people will be facing in the future if something like this were possible. So just to summarize some of the research works, I only highlight like 6 here, but there's a lot more going on. At least in these 6 works, I just want to say that in general, inclusion is about recognizing people that are diverse. There are gaps between people, and these gaps can lead to exclusion. So I look at AI and XR as the potential to fill this gap. By understanding how people think, feel, and act, we can assist and help others in more ways than you think, and push the limits of humanity beyond what it is today. So that's how I look at AI XR overall and a summary of the work. Now, for the remaining 10 minutes, I want to share a couple of more sort of, I guess, topics of discussion, and also to bring forward a couple of understanding about AI XR in general that I'm surprised probably have not been mentioned in the past few speakers, but I think it's important to know. So the first one is about the AI XR continuum. So you've probably seen an image like this, or if you're an XR researcher, you've seen an image like this. I think yesterday showed an image like this. I think Mark also showed this in the first day. It's the XR continuum, right? From real environment to virtual reality, and how we have augmented reality, augmented virtuality, mixed reality, so on and so forth. So this has been around for quite a number of years. But I think this continuum is not as important as it is now anymore. The more important continuum is the AI XR continuum, where we have from virtual world to real world, and how the different form factors of devices. We have the VR only headsets, right, all the way to the left, and we have the AI glasses all the way to the right. But the best point to be is actually, or at least what we are thinking, is the middle point, the MR glasses, the little bit of the best of both worlds, where you have things like the Meta Orion or the latest Snap spectacles. We don't have this in our hands yet because they are not the most usable at this point, I assume. But that's where we want to be. That's where companies want to be, where we have the good degree of immersion when we want it to be. We have the right level of AI assistance where we want it to be, and it's all comfortable and hopefully well priced. So it's supposed to be here, right? That's where we want to be. It's comfortable, it's useful, it's all sunshines and rainbows. That's the area. Otherwise, it's either uncomfortable or gaming focused, or it's comfortable but very low immersion or audio only. But is it really all sunshines and rainbows? So this is something that I think is important to discuss when we're all exploring AI and XR, is the cost or the hidden cost of AI and XR. So the cost of XR is a bit more straightforward, I think. It's that it can be the middle ground between mildly entertaining paperweight or your house mortgage, right? If you hold a Vision Pro, clearly it's not the most expensive thing. You're a rich person. Otherwise, you're sponsored by someone else to have it. But in most cases, like we discussed earlier, it's something that you put aside after a while. It becomes a paperweight. And so the cost is just the amount of money that you spent on it. It's quite straightforward, the cost of XR, at least at this point. The cost of AI, though, is not, because we also discussed, right, that AI is more back-end, XR is more front-end, so it's more clear to us. But what is the cost of of AI? A very important point to know is the environmental cost of AI. And these are just some of the articles that popped out in the last couple of years, very, very new. Do you know that AI requires fresh water to cool? You can't just dump it into the sea. It doesn't work that way. You need fresh water, drinkable water. So this is just 2022, so it's much worse this year. Google, Microsoft, Meta, they use estimated 580 billion gallons of water to cool their data centers. And that's enough water for 15 million households. Then there's an article a couple of months ago about Elon Musk's XAI facility basically polluting South Memphis. So I let them know there is the methane gas. They use methane gas actually to power, and people around there are suffering from it. Also, Sam Altman, OpenAI, he said that just by saying thank you or please and thank you, you don't need to say that, but some of us do when you use ChatGPT. Just by saying that, it costed them tens of millions of dollars. So it's nice, I guess it's nice to be nice to AI, but there's a cost to be nice to AI as well. So that's electricity cost, right? Environmental cost, water cost, so on and so forth. There's also the cognitive cost of AI. How often do you now find yourself asking AI the simplest of questions when you know you could just take maybe 10 seconds more to answer it? I myself is guilty of this. There's once I was thinking like a very simple math question, and I busted out ChatGPT on my phone, like, hold on, what am I doing? I can just, try to think in my head, and I can calculate that, but I just had to use GPT. And so, this person, he was talking with a Stanford student, and this student kept pausing mid-sentence, searching for words, not complex words, basic ones, like his brain was buffering. If you find yourself buffering in your brain for simple questions, that's a problem. That's actually quite a big problem. And a couple of research papers have already published online, analyzing brain signals, EEG signals, about how we're all much dumber, basically, now with the use of AI. So ideally, AI is supposed to help us, right? Not replace us. Our brains should still function, and it should help our brain functions better. But by the way, how we are using it today, how easily accessible it is doing the opposite. So I just urge you to be careful. Think properly about the use cases of how you're going to be using AI before you try to delve and jump deep into it, because there's a lot of cost for AI. I'm not saying it's all doom and gloom, obviously. AI is very useful. There's a reason why it's around and everyone's using it. But just, give some thought into it. So AI is meant to catalyze, not cannibalize XR growth. But to me, it's not about just AI and XR. We have to think on the human side. So AI and XR is to catalyze people, not cannibalize them. And there's also some talks about AI XR symbiosis, how AI can benefit XR, how XR can benefit AI. But that's not the important question to me. It's how AI XR human can be achieve symbiosis, how we can benefit each other. And so I just hope that with this discussion in mind, when you choose to explore and use AI and XR tools, understand its cost and understand its social impact to the people around you, right? So I talk like all this work is done by me. It's not just done by me. It's done by a group of people. You see Tamil's face there as well. So huge thanks to all these amazing people who have worked with me on different research ideas, research projects. And I look forward to any discussions. If you want to see more future other works that I have worked on, feel free to look at my website. That's a QR code. Or you could email me or just catch me while I'm around. I'm still around for the next couple of days. Arguably I don't do as much hands-on as I used to anymore. So it's harder for me to help with the hands-on stuff. I think Tamil and Richard can do that better. But I'm going to talk about strong directions, research topics, so on and so forth. Then I'll be happy to engage in conversations. Thank you.
There's another question online, Pai, about the vision loss simulation app as well. Is that also available, or is that?
That's not an app. That's hardware. That's hardware based. So unfortunately, that's stuck in the research world for now, at least.
And then there's a final question. Another question saying, have you considered another metaphor? I'll read the whole question actually from one. Thank you for your presentation. May I ask for the portable safe room project? Since the only stimuli present in VR would be visual and audio stimuli, have you considered for besides a physical room to introduce calmness in the user, such as a meditation app on iOS?
Yeah, well, that's a good question, and there are actually already quite a lot of meditation apps. In fact, if you own a headset with you now, there are meditation VR apps in the Meta Store, which you can purchase, download, and try it out yourselves. And the good news too is that when the paper gets accepted, we will actually have the project up on GitHub. So you can download it, install it on your Quest. It should run locally fine. We're not using any special sensors or anything, so it should run on most standard headsets, and you'll be able to experience it yourself. Otherwise, if you want to do works on, there's a couple of research on meditation, but otherwise there's also a lot of apps online already on meditation in VR, which tries to sort of regulate your breathing and puts you in a nice calming environment. So there are a couple of works like this already. So if you want to experience them, they're available easily on stores, Meta, Steam, so on and so forth.
Great. And then Ashita has a question as well. Maybe Ashita, do you want to unmute yourself and ask your question?
Yes, I could. Thank you so much, Dr. Pai. It's nice to see we have a similar last name. And also that I used to live in Singapore for a bit, really close to Malaysia as well. But yeah, your presentation was really insightful, and especially the well-roundedness of like connecting the human aspect to all that we're doing. That's technology advent. So one thing that I've been always thinking, and also with like technologies like avatars, robots, VRs, ARs, they are often like positioned as breakthroughs, like what we're doing is super cool, but at the end of the day, at the core of the issue, they're just interfaces, and there's anything that we're doing is an interface to the human component. So meanwhile, the real complexity that we think is in the systems, like the ethics of it, like how do we actually get humans in the sustainability aspect. So sometimes I wonder, with the growing environmental toll that AI is having, and the cost of these interactions, per gallon, and everything that we think that's more nuanced. How do you actually think about innovation? Like, is it truly necessary versus are we just like overkilling it with more AR, more VR? Because sometimes this same outcome could be accomplished with just an app. Like the previous question asked, like, could this app be on an iOS rather than like a VR safe room? Like, how does that keep you in your work?
Yeah, thank you. Yeah, that's great. Were you the one who also are saying that immersion? Yeah,
Mhm.
that's great questions. So,
Thank you.
yeah, to answer that, it is one of those questions there's no definitive answer, isn't it? Because as researchers, at least a lot of us here are, our work is to push the boundaries of innovation, right? To explore where no man has gone to before. And to do this is the only way is to really just kind of pushing further. And it's the way how the new systems appear to us, it's usually not immediately apparent how useful it is. Usually it only becomes more apparent after several years or even decades down the line, right? If you look at research out there on smartphones with touchscreens, um, the actual research for these works is way decades before we actually started using them. And we can't predict this future. We can't predict how ubiquitous it will be, whether it will be the next big thing, whether it will be truly useful the way how we say it is. This thing, we can never predict. So our only way is to just keep trying to push the boundaries, but we have to always acknowledge the cost of it, right? So the way how I feel is that it'll be good to, if any researchers publish works in AI or XR or any of the sort, emerging tech, I think that it'll be nice to always have during the discussion section to always talk about the limitations. Well, there are limitations, but more about also the hidden costs. So with all the AI papers out there, with how amazing AI can be, there is almost no little to no sections in the research paper itself saying like, what's the cost of it, right? What have we sacrificed to put it in place? And I think this needs to be as transparent as possible. The issue with AI is the lack of transparency. And actually looking at it now, the issue with emerging tech in general is the lack of transparency. In the front, we say it's this amazing thing everyone will be using in the next 5, 10, 20 years, but everything comes at a cost, right? The more impactful it will be, the more costs that you pay as well, isn't it? And also the higher chance that it can be misused. The more transformative it is, the higher chance it can be misused. That's also a very tricky thing. So these things are always topics that should be discussed, I think, whenever any researchers try to publish these papers. I hope this answers your question.
Yeah, thank you so much.
Question. But first of all, thank you, Pai, for bringing up very important issues. I'm very intrigued to see that you mentioned that the headsets order is less getting and I think most of the thing has something to do with how the technology embodies with us as human beings. And you mentioned at the end of your presentation about the continue for the devices and also the human symbiosis. Now, I've been working on the human AI collaboration maturity framework, which actually can include the XR in it. Now, the question is, when do you think, so now we have the, let's say, when you say about the integration, right? So we can have some application, for example, to touch the brain to help the Parkinson people. It's already done, right? But that is going to be quite different when you try to make a different reality with the XR technology into the brain, so someone can have a different world. You can say. So, how do you think it's going to be in the future with regard to the last mention that you mentioned about very important symbiosis between the XR, AI, and human? Do you think it's going to go that way with regard to the XR, the AI technology, or is it going to be different ways? Like at the moment, you see the continuum that you look at the smart glasses, right? So is it going to be there into the brain or stop at smart glasses, still like
Well, okay. Yeah, thank you for the question. Yeah, you know, I don't have a crystal ball. Every time people ask me what I think of the future, there's no, you know, I'm also known to be doing a very poor job in predicting the future. But at least from what I can say is that next, let's say 3 to 5 years, it will probably still be within this continuum of a wearable device. I suppose what you are saying is that is there a potential to be the next step, right? Something like an implant or like a contact lens, the size of a contact lens for an AR system, or direct interface with the neurals of the brain, AI with real intelligence, or like a matrix future. Yeah, I mean, I don't know if this is going to happen and how long it's going to take. It is accelerating, is it an accelerating pace? So perhaps within the next, well, if I'm just going to throw it out there, I'll say that maybe within a decade, the neural interfaces will grow very large, but at least within the next 3 to 5 years, perhaps we're still on the wearable side. Whether it'll reach the contact lens point, it will require significant progress in power and vision. Actually, right now, one of the big things that's pulling us back is power, right? Batteries. We don't have that big leap in battery technology yet. Recently, I think like recent smartphones have this silicon carbide or silicon something, which is like the next leap in batteries, but still not the point that we want it to be, or for these devices to reach the point of how we envision it. So, you know, the direct answer is I don't know. The indirect answer is that hopefully by 10 years, it will have a direct neural interface. People are obviously working on it, right? Neural links, so on and so forth. A lot of BCI research going towards this direction. So yeah, hopefully it reaches the point.
We should stop. There's a couple more people
Oh,
online
yes.
who asked questions, so maybe you can answer their questions in the chat.
Yeah, sure. Yeah, I can do
so
that.
Daniel's going to give us a presentation.
Okay, yeah, sounds good.
So thanks everybody, and let's thank Pai again. That was really great.